Hi everyone, so in this first lecture series, we are going to cover on the basic of statics and what are the basic measurements involved in the calculation of statics. At the same time, we will also look into the fundamental principles behind statics. Statics is actually a branch of engineering mechanics which deals with the motion of a body when it is being subjected to force or load. Okay, so let's do a very simple test to illustrate the concept of load being applied to the body. So look around you, take for example a pen and put it on one hand, and on the other side, using your palm, you try to push this two different material onto your face. Okay, probably you will feel a different intensity from the side of your pen compared to the side of your palm. Probably the intensity is higher at the side of the pen compared to the palm. But then you are applying the same force, only the corresponding pressure is different. So the force that you applied on your face is known as the external force because it happens outside your body. So the body that you are studying is like your face. So your face or the body of a material will try to resist the force being exerted to it. Okay, so every time you apply some kind of force to your face or to another material, the material will try to resist it from deforming. Okay, so the resistance of that load is called internal force or internal load. Okay, so the body that you're studying, whether it is your face or a steel, so we wanted to know what is the effect of external load caused onto the body. Okay. Sometimes if I apply an external load onto a body, for example this body, it doesn't budge, it doesn't deform, it doesn't move. So we can say that all the external force being subjected to this body is in equilibrium or it is balanced. So because it is balanced, it will not cause this body to move. But then certain kind of force, if I were to apply it, maybe the body will accelerate. Okay, so any changes to the velocity of the body, it falls under the study of dynamic. If the body doesn't move or if the body remains static, then that is what we are interested in this subject. Okay, sometimes if the body is already moving in a constant velocity and if we apply additional force to it, the velocity remains, it doesn't accelerate. Again, that is also the subject under statics. Okay, so statics and dynamics are the two main branch under the study of engineering mechanics. The concept of statics are being applied in many engineering applications. For example, in lifting the load using mobile crane, we can calculate the corresponding force subjected to the crane by constructing the free body diagram. If the force being applied to the crane is not balanced or not in equilibrium, then there is a high chance for the crane to overturn like this. Another application of static is the design of the bridge cable. Similarly, structural engineers would have to determine a balanced force to ensure the bridge are being held in place. Incorrect calculation will cause the bridge to collapse. Oh dear, that's deadly damage, man. We definitely don't want that to happen. And if you remember the very recent issue happening at SUKE Highway, a concrete panel fell on a car because the cable, which was supposed to hold it in its place, snapped from its fixation. Luckily, no life was lost during that incident. So, you see, statics is a very significant subject to be applied in many engineering applications. Okay, before we proceed with the application of calculation involved in statics, we have to understand the fundamental concepts which involve the basic quantity, the idealization, and then law of motion, and also the law of gravitational attraction which governs most engineering mechanics problems. Let's look at the first one, which is basic quantities. The basic quantity, as the name goes, is the basic of measurement with a specific unit according to the international standard, or we call it the SI unit. The first quantity is length, and the international standard for length is meter. That's very common lah. The second quantity is time. Instead of measuring the time in hours, the international standard or SI unit for time is seconds. The third quantity is mass or GSIM. Mass is defined as gravitational attraction of two bodies, and its SI unit is kilogram or kg. If there is gravitational pull, then there is a mass. No gravitational pull, probably no mass. Okay. Finally, the fourth quantity, which we commonly use in statics, is the force, as I keep on mentioning earlier. So force is the push or pull effect subjected from one body to another body, and the SI unit for force would be Newton. The second fundamental concept that we need to consider in mechanical statics is idealization. Idealization is a kind of simplification in modelling any mechanical problem so that the computational process would be much more easier. Lagi senang you nak buat calculation lah. So remember the analogy that I gave to you earlier. Mechanical problem would involve some physical object, or we call it the body. Bukannya body manusia tu. It's like a physical object as a whole. So we term it as a body. So the body is subjected to external load. The external load may be pushing the body, or it may pull it outward on the opposite direction. Okay. The first idealization or simplification is if we assume the body to be a particle element. The second idealization also involved the body. In certain cases, we assume the body to be a rigid element instead. And the third idealization or simplification involved assuming all external load to be a concentrated force instead. In the first simplification, we assume the body to be a particle element. In that case, we can consider the mass of the particle, but we can neglect the size in the calculation. So, when we neglect the size of the calculation, the variables in our calculation also becomes less, meaning jalan kerja lagi pendek lah. The example is, if you are studying the orbital motion of the Earth, relatively, the size of the Earth is so small compared to the orbital motion. So, in that case, we can consider the Earth as a particle element. Another cool example here is Mr. Spider-Man holding two halves of the barge. So let's say you need to calculate the tension force caused by his web thingy. So relatively, his size is small compared to the barge. So to make your calculation much more easier, you can consider him as a particle instead. And this is how the free body diagram would look like. The second idealization or simplification is to assume the body that we are studying to be a rigid body. Rigid body ni, it involves a combination of many particles. For example, look at this train wheel. So, if I redraw the wheel in a mesh element, and let's say the nodes of the mesh element is the particle, there are external force subjected to the train wheel from the train rail. So we assume the tire as a rigid element because we assume that even after the load is being applied, all the position of the particles remains the same because it's a rigid material. Rigid meaning keras. So we kind of neglect the phenomena of deformation in our calculation. So therefore, the material properties in this case can be neglected. The third simplification is to assume all external load to act only at one point of the body, or we call it a concentrated force. Taking the same example of the train wheel, the actual force distribution between the rail and the train wheel is as shown. It have a kind of force distribution along the contact point. But then, we can actually simplify the loading pattern by assuming the distributed load to be a single concentrated force instead. So, this kind of simplification only applies if the area over which the load is being applied to the body is very small compared to the overall size of the body. Now, let us look at the third fundamental concept, which is the law of motion. There are 3 Newton's law of motion which govern most theoretical development in the calculation of engineering mechanics. The first law of motion stated that any object at rest will remain at rest, meaning dia takkan bergerak lah, unless it is subjected to an unbalanced force which causes it to move and accelerate. The same law also stated that the object moving in a straight line with constant velocity will remain in this state unless it is subjected to an unbalanced force. Like this ball, if it moves in a constant velocity, it will move in a straight line until it is being stopped by the net. The second law of motion stated that if the body is being subjected to an additional force, so the body will move and accelerate in the same direction of the force and the magnitude, which is directly proportional to the force being applied to it. So the more force you apply to the body, the higher acceleration the body will experience. Finally, the third law of motion stated that if we apply an action force onto a body or a particle, then there will be a reacting force trying to resist the motion of the action force. So this reaction force between these two particles are equal value in opposite direction and in the same line with the action force. Or in other words, we can say that the loading of the action force is equal to the negative loading of the reaction force. Now, let's look at the final item in the fundamental concept, which is the gravitational attraction. This law stated that there are mutual gravitational attraction force between two bodies. For example, if you're bouncing a ball and it will bounce back to the earth, that's because of the gravitational attraction. So, such force is usually measured in the quantity of weight, by which the mass is multiplied with gravitational attraction. So this equation, W equals to mg, is some basic physics equation over here, so I don't want to elaborate it much further. Okay, the final section of this lecture series is related to the unit of measurement. Unit of measurement is very important to ensure that you got the right unit and value of the magnitude during your statics calculation. In this subject, we are going to play around with loading and force a lot. So force, or F, is equals to ma, which is mass multiplied with acceleration. The basic unit for mass is kilogram, whereas the unit for acceleration in its SI form is meter per second squared. So 1 kg meter per second squared is equivalent to 1 Newton, which is the basic quantity for force. Sometimes during our calculation, we will get a value which is too large or too small. For example, lepas buat kira-kira, you dapat the value of force to be 7 million Newton. So, in mathematics and in engineering especially, we don't like to see too many numbers. It is not convenient to tell people that the force value is 7 million Newton. Okay, the more convenient way to represent such value is by using prefix. Again, prefix is a recap of your physics or math class during your high school. The prefix for 1 billion or 10 to the power of 9 is a giga, and the symbol is capital G. So if you got a force value of 1 billion Newton, then you can simply represent it with 1 giganewton. Okay, the prefix of 1 million or 10 power of 6 is mega, and the symbol is capital M. The prefix of 1000 or 10 power of 3 is kilo. Okay, that is if the quantity is too large. So in the case of the quantity, if it is too small, for example, 0.001 or 10 to the power of negative 3 is equal to a milli. 10 power of negative 6 is micro. And finally, 10 to the power of negative 9 is nano. So do we have to memorize this? Yes, of course lah, because you are an engineering student, so you have to know this by heart, okay? Many engineering calculations in other subject and in other course will adopt the same prefix. Okay, now let us look at an example of using prefix. Okay, from this question, we know that the Newton, the capital N, is actually the basic quantity for force. Okay, and the prefix involved in this equation would be the milli, the small letter m, and also the giga. So that is the prefix. Okay, so in order to solve this, let's convert all the prefix into its numerical or exponential form. Carry over the 50 magnitude down here, okay, and then we know milli, the exponential value for milli is 10 to the power of negative 3. So you put it there and we remain the basic quantity of Newton as it is, and then the 6 will remain as it is, and G, capital G, is actually a prefix for giga, and the exponential value for giga is 10 to the power of 9. So we just rewrite that 10 to the power of 9 multiplied with the n value. So we don't have to change the n value. So you can actually use your calculator, or you can simply calculate this multiplication, and you will get a value of 300 multiplied with 10 to the power of 6 Newton squared. Okay, don't forget, because a Newton is multiplied with another Newton, so it becomes Newton squared. Remember, the exponential value for 10 to the power of 6 is actually kilo, so you can substitute that 10 to the power of 6 into kilo instead. So the final answer with the appropriate prefix is 300 kilo Newton squared. Okay, now let's look at the second example. In this example, we know there are a length quantity involved, the meter, and also a force quantity involved here. So let us just convert all the prefix into its equivalent exponential form. Okay, 400 milli multiplied with 10 to the power of negative 3 meter remain as it is, and then 0.6 mega, which is equivalent to 10 to the power of 6 exponential value, and then the n here, and don't forget the power of 2 for this bracket. Okay, now let us first solve for the squared value first. So 0.6 times 10 power of 6 Newton power of 2 would be equivalent to 3.6 times 10 to the power of 11 Newton squared. So we are solving the power 2 problem first, okay, and then we just carry over the first impression, which is 400 multiplied with 10 to the power of negative 3 meter. So from here onward, you can actually just use your calculator, and you will get a value of 1.44 times 10 to the power of 11 meter Newton squared. Okay, we know the prefix are usually in the multiplication of 3. 3, 6, 9 or negative 3, negative 6, negative 9. So we can convert this 1.44 into an equivalent exponential value of 144 multiplied with 10 to the power of negative 2. So it gives the same value of 1.44. You carry over the 10 to the power of 11 downwards. Okay, so 144 remain as it is, and then you know 10 to the power of negative 2 multiplied with 10 to the power of negative, 10 to the power of negative 2 multiplied with 10 to the power 11 is equivalent to 11 minus the 2, which is 10 to the power of 9. Okay, so 10 to the power of 9 is equivalent to the prefix of giga. So you can replace the impression to be 144 gigameter, and then I put a dot here to differentiate the length quantity and also the force quantity, dot with Newton squared. Left side is the impression for the length, whereas the right side is the impression for the force. Okay, you can try this on your own, and the answer is given here. Okay, that's about it. That's about introduction to statics. Very simple. Some few laws governing the equation of statics and some fundamental theories behind the subject of statics. So please do the exercise given and submit it as part of your e-attendance activity. Okay, so till then, see you in the next lecture series. Bye-bye.